Good day, doctor and fellow friends. My name is Lita E, matrix number J2280246. Today, I'm going to present the introduction part of my group poster. Let's start with the introduction. Advanced polymer composites are widely used in industry due to their lightweight, high strength, and versatility. Epoxy resins are popular for their excellent mechanical and chemical resistance, while the polyvinyl alcohol, which PVA, offers the flexibility and firm forming properties, making it suitable for composite enhancement. For the problem statement, epoxy composite, while strong, can be brittle. By adding the PVA, can improve the flexibility and processability, but achieving uniform dispersion and consistent properties still remain a challenge. These factors are crucial for material used in applications like Robocar, which require both strength and adaptability. Why this material was chosen? The epoxy PVA system was selected to combine the strength of epoxy with the flexibility of PVA. This study compares it with pure epoxy to evaluate the improvement in performance for potential use in lightweight robotic system. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Insyirah Natasha binti Samizi. My metric number is J2280347. Okay, for material, to build our Robocar, we use a combination of electronic, mechanical, and structural components. First, we use the microbit board as the main controller of the robot. It processes the control signal and communicate with the motor driver. We use the electronic motor driver, which is compatible with microbit to control the movement of the wheel via two 360-degree continuous rotation servo motor. These motors are connected to two wheels, allowing the robot to move forward, backward, and turn. The Bluetooth module, which is built into the microbit, was used for wireless communication, enabling us to control the robot remotely. For power, we use an 3A battery holder and 3A batteries to supply energy to the components to hold everything in place. We use screwed wires and a hot glue gun for assembly. As the game ball, we use a ping pong ball which is light and easy to push. For the Roboca body, we use epoxy rising and polyvinyl alcohol rising to create a lightweight and durable structure. Okay, for design product, now let me explain the design of our Robocar. Our Robocar is designed with a symmetrical chassis which help to maintain balance during sharp turn or collisions. The symmetrical design also allow even weight distribution on both sides, reducing the risk of tipping over or losing balance. At the front, we add a plow or guard, which function to push the ping pong ball towards the goal. This help control the ball and improve gameplay efficiency. We also make sure the Robocar has a low center of gravity, meaning the heavy components are positioned closer to the ground. This gives the Robocar better stability during high speed movement and quiet direction changes. Additionally, the design is modular. Each component such as motor, wheels, and circuit board is individually mounted using screw and hot glue. This makes it easy for us to maintain, repair, or upgrade any part of the Robocar. In conclusion, our Robocar was designed not only for functionality but also with a focus on stability, easy maintenance, and adaptability to real game conditions. That's all for my presentation. Thank you.
Assalamualaikum, my name is Muhammad Ali Fitri bin Maris and my number metric is J2280239. I will present about methodology for our group is Group L. For our methodology, we began by measuring the appropriate amount of PVA powder and dissolving it in hot distilled water. The dissolved PVA solution was then mixed into epoxy and allowed to dry at room temperature. Once dry, We conducted a series of tests, including visual inspection, optical microstructure analysis, and thickness measurement. This was followed by tensile testing to determine the material strength and elongation rate. Based on the result, we proceed to design and construct our Robocar using the prepared material. The microbit program and coding were then inserted into the Robocar system. Finally, the Robocar was adjusted and optimized to meet the requirement of the Robosoccer competition, which involved using a ping pong ball. Thank you.
Assalamualaikum, my name is Herman bin Samad, my metric number is J22A0328. So in my part is result. I will brief present the tensile test result for epoxy and epoxy plus PVA. So the purpose of this test is to determine mechanical property like tensile strength, Young modulus, elongation, and maximum force before failure. In this study, two samples were tested using a tensile machine. Both samples were pulled until they broke, and force and extension were recorded. The results show the epoxy has higher tensile strength and stiffness but is less flexible. Epoxy plus PVA, on the other hand, recorded higher peak force for lower stress, indicating it is more elastic and flexible. So this is the result from our test. For test 1, which is pure epoxy, we recorded a higher tensile strength of 7.09 MPa and a Young modulus of around 97 MPa, indicating the epoxy is stronger and stiffer. However, test 2, the epoxy plus PVA composite, showed a lower tensile strength of 3.12 MPa, but it reached a higher peak force of 242.3 Newton, which means it can absorb more load before breaking, but with less stress. If we look at the graph at the bottom, we can clearly see the difference. The blue curve represents epoxy and it breaks at a lower elongation. The purple curve, which is epoxy plus PVA, extends much further and show more flexibility. So the epoxy is suitable for application that need high stretch and stiffness, but it is more brittle. Epoxy mixed with PVA is more elastic and flexible, which make it better for non-structural or packaging application. Okay, now we move to next is optical microscopy (OM). I will explain the optical microscopy (OM) result based on the fracture surface of epoxy and epoxy plus PVA sample after the tensile test. So the purpose of the OM test is to observe the fracture surface under a microscope. This allows us to see the failure characteristic, such as how the material broke, surface texture, and any visible defect at a microscopy level. In this study, the epoxy sample showed a smooth and flat fracture surface, which is a clear sign of brittle failure. This means the material broke suddenly without much plastic deformation. On the other hand, the epoxy plus PVA sample had a rough and more fibrous surface, indicating ductile failure. This shows that the addition of PVA improved flexibility, allowing the material to stretch and deform more before breaking. So the optical microscopy helped confirm the mechanical behavior seen in the tensile test. Epoxy is brittle, while epoxy plus PVA is more ductile and substable for application that require flexibility. So this is the overview of optical microscopy of epoxy. We can see the surface at the bottom. We can see the thickness. And then this is optical microscopy result of epoxy plus PVA. The top is surface and the bottom is thickness.
My name is Nur Izzati Akmal binti Nur Azmi. J228038 will present about discussion. Present the result of tensile test comparing epoxy and epoxy plus PVA. Tensile strength, Young modulus strength at peak, and another parameter help us understand how this material respond to force and stretching. Epoxy has a higher peak strength and Young modulus mean it is stronger and more rigid. It can withstand more force before breaking, make it ideal for application needing durability and load-bearing capacity. However, its strength at the peak is lower, suggesting less flexibility. Epoxy plus PVA, on the other hand, has a much higher strength at the peak, indicating it can stretch significantly before breaking. It means it is more flexible, but its peak strength and Young modulus are lower, making it less stiff and more likely to deform under the force. This difference suggests that epoxy is better for rigid structure, while epoxy plus PVA is useful for application requiring flexibility. Depending on the need, modification can be made to balance strength and elasticity for specific use. Thank you.
Assalamualaikum Doktor. My name is Mia Binti Nordin. My matrix number J2BA0167. Today I want to conclude about conclusion. To summarize, epoxy has great strength and rigidity, making it ideal for rigid and load-bearing application. However, it is brittle and less pliable. By adding PVA, the composite becomes more flexible and can strain further before breaking, but it loses some strength and stiffness. As a result, epoxy or PVA is more suited to application requiring flexibility, such as lightweight robotic component. The decision between epoxy and epoxy or PVA is based on whether strength or flexibility is more relevant for the desired use. Thank you.